Hi everyone. Today we will be completing our notes on factoring polynomials in the form x squared plus bx plus c. So an example of this would be something like x squared plus 8x plus 12. So this is a quadratic trinomial, and we want to factor this into two things that we're multiplying together, two groupings. In this case, it would be a binomial times a binomial that gives us the product x squared plus 8x plus 12. So before we consider the general form x squared plus bx plus c, let's try this exercise here. I'm looking for a pair of numbers, either positive or negative, that multiply to 21 and add to 11. So think about that. Those numbers, the answer is 7 and 4. 7 times 4 is equal to 28, and 7 plus 4 is equal to 11. Let's try another. What two numbers multiply to 12 and add to negative 8? The answer is negative 6 and negative 2. And one more. What two numbers multiply to negative 45 and add to 4? This one's a little tricky. The answer is 9 and negative 5. 9 times negative 5 is equal to negative 45, and 9 plus negative 5 is equal to positive 4. So let's consider these binomials multiplied together. We're going to use the distributive property or a FOIL to multiply these two binomials together. So if you remember, we multiply every term in the first polynomial by every term in the second polynomial. So x times x is x squared. X times 5 is 5x. Inner 4 times x is 4x. And 4 times 5 is equal to 20. And then combining like terms, we get x squared plus 9x plus 20. Let's try another. Y minus 1 times y minus 8. So first, outer, inner, last. So first, y times y. Y times negative 8 is negative 8y. Negative 1 times y is negative y. And finally, negative 1 times negative 8 is positive 8. Combining like terms, y squared minus 9y is plus 8 is our answer. Okay. So take a look at your answers. Do you notice anything about the numerical values in the factors and the numerical values in the answer? So take a look at, I'm looking at this constant term and this linear term. So like, what's the relationship between 4 and 5 and 20? Or 4 and 5 and 9? Likewise, what's the relationship between negative 1 and negative 8 and 8? And negative 1 and negative 8 and 9? So what do you notice? Go ahead and write your answer below. I notice that the middle numerical value in the answer, so that's that coefficient of the linear term, is the sum of the numerical values of the factors. Okay, so the middle numerical value in the answer, or the coefficient of the linear term, is the sum of the numerical values of the factors. The last numerical value in the answer is the product of the numerical values in the factors. Okay, so the last numerical value in the answer, or the constant term Okay, the coefficient of the linear term and the constant term, this applies when you are multiplying a linear binomial times a linear binomial. Okay, so let's try one more. Here I have b plus 2 times the quantity b minus 10. So we're going to multiply these out. So we have b times b is b squared. B times negative 10 is negative 10b. 2 times b is 2b. And 2 times negative 10 is negative 20. Combining like terms, we get b squared minus 8b minus 20. Okay? So again, you may have noticed that the sum of 2 and negative 10 is equal to negative 8. And the product of 2 and negative 10 is equal to negative 20. So what we want to do here is, for this lesson, we're going to be getting the answer here, the simplified expression. And then we want to get back to its factors. Okay, so this is called factoring polynomials. All right. So here's the general form, x squared plus bx plus c. Let's consider the example, x squared plus 9x plus 20. Okay, so here's our simplified quadratic trinomial that I want to get back to the original factored form. Okay, so we're looking for two numbers that multiply to 20. So two numbers that multiply to 20 that also add to 9. So c is 20 and b is 9. So two numbers that multiply to 20 that add to 9. The answer is 4 and 5. So what we're going to do is we're going to write out our factors, x plus 4, that's a positive 4, and x plus 5, and that's a positive 5. And then let's use the distributive property to just check our work here. So x times x is x squared, x times 5 is 5x, 4 times x is 4x, and 4 times 5 is 20. And then combining like terms, we get x squared plus 9x plus 20, which is good. That's what we were hoping to get. That's our original problem. Okay, so notice that to factor quadratic trinomials, we find the factors of the third term, c, the constant term, that add up to b, that middle term. Okay, so let's consider x squared minus 12x plus 35. So c in this case is 35, and b in this case is negative 12. Be careful with that negative. So the two numbers that multiply to 35 and add to negative 12, the answer, negative 7 and negative 5. So I noticed that negative 7 and negative 5 add to negative 12 and multiply to positive 35. Be careful, the answer is not positive 7 and positive 5 because those don't add to negative 12. So if I were to write out these factors, x and a negative 7, so x minus 7, and a negative 5, x minus 5, and let's check our work by distributing it. We have x squared, outer, negative 5x, inner, negative 7x, and last, plus 35. And combining like terms, x squared minus 12x plus 35. So yes, we did this correctly. Our factored form, I'm going to circle my answer here. Our factored form, x minus 7 times x minus 5. Example 3, x squared plus 6x minus 27. If you want, go ahead and pause this video and you can try it on your own, or you can follow along with me. Two numbers that multiply to c, negative 27, that add to positive 6. The answer, 9 and negative 3. So then this trinomial factors to x plus 9 and x minus 3. Let's check our work. First, outer, inner, last. First, x times x is x squared. Outer, we get negative 3x. Inner, we get 9x. And last, negative 27. Combining like terms, we get x squared plus 6x minus 27, which checks out. All right, go ahead and flip the page. Now we will see some special cases. One of those examples is x squared minus 100. something you might immediately notice is there's no middle term here. There's just the x squared term, the quadratic term, and the constant term. There is no linear term in this case. But you might also notice that both of these terms are perfect squares. X squared, of course, is a perfect square, and so is 100. It's a perfect square of 10. So we're looking for two numbers that multiply to negative 100 and add to that middle term. I can also write this expression as x squared plus 0x minus 100. Right? Having 0x, that whole term would just drop and would simplify to x squared minus 100. So we want these to add to 0. So the two numbers that multiply to negative 100 and add to 0 are 10 and negative 10. So then my answer, x plus 10 times x minus 10. And that's my answer. Well, let's go ahead and check. So x times x, first, outer, inner, last. X times x is x squared. Outer, negative 10x. Inner, positive 10x. And last, minus 100. Combining like terms, you may notice that the negative 10x and positive 10x cancel out, which is exactly what we want, because we want to end up with x squared minus 100. We lose that linear term. Okay? All right, let's get some practice. So 1 through 4, I encourage you to pause the video and try these on your own, and you can check your work. 1 through 6. All right, unpause when you're ready to check. All right, so for number 1, numbers that multiply to 24 that add to 11, we get x plus 8 and x plus 3. Number 2, numbers that multiply to 24 that add to negative 10, x negative 6 and x and negative 4. Number 3, numbers that multiply to negative 22 that add to negative 9, x minus 11, x plus 2. Numbers that multiply to 15 that add to negative 8, x minus 5 and x minus 3. And we got two more. So number 5, numbers that multiply to negative 18 that add to 7, positive 9 and negative 2. X plus 9, x minus 2. And finally, numbers that multiply to negative 30 that add to positive 1. The answer, x plus 6 and x minus 5. Positive 6 and negative 5. Okay? All right, so this has been our notes on factoring polynomials. I hope it's been really informative for you. We're going to get a whole lot of practice on this. All right, we'll see you tomorrow in class. Goodbye, everyone.